Yeah, so we're going to be talking about how to configure the runtime. Probably for various things, you've in ZIO1 you did different things to configure the runtime, and a lot of times you'd work with this platform thing, or in earlier ZIO2 versions, it was like a runtime config thing. And so we'll look at kind of how that's evolved and some of the improvements that result from that. So I think I'm going to start off here. I'm just going to make a little folder for us. I'm just going to call us configuration, and not like in a narrow sense of like config, like all we're doing is loading configs, but more just that we want to be able to configure the runtime, maybe for logging, maybe for monitoring, maybe for all sorts of different things. And I'm going to create a new file here that maybe I'll call Scala.
Mm-hmm.
And
the size 1 or 2 points.
Oh, yes, we'll definitely do that. There we go. And maybe we can put the side here. Okay, perfect. And I'm also going to do one more thing for reasons that will become apparent in a little while, which is right now I'm actually going to put this in the ZIO namespace. And the only reason I'm doing that is one of the things I'm going to want to show off is some functionality around the supervisor. And I actually just did a PR last week to make that interface public so that if you're outside the ZIO namespace, you can extend that interface. But I want us to be able to work off of RC6. So the little bit of hacky workaround to kind of be able to do that is we'll pretend we are in the ZIO namespace again. Kind of once the next version comes out, you'll need to do that because that will not be package private anymore. But that'll just let us implement the supervisor functionality. So we want to look at that. So the basic idea is in ZIO1, we configured the runtime through this thing called the platform. And so if you wanted to like provide it an executor, or you wanted to provide it with a supervisor or something, you would always do it through this like platform thing. And in earlier versions of ZIO2, this got renamed to something called runtime config. And so this runtime config, oh, hold on, let me just check. Oh, okay.
That was me.
So this runtime config was basically just this like case class. So it'd be like runtime config, and it just had a bunch of, compile's not made up the correct things that were in the runtime config, even though that's a valiant try, but it would be things like it would have the executor that was an executor, and it would have the blocking executor that was an executor. And then in ZIO2, it would have like the loggers, which were, I think, well, for a while it was one logger, and at some point it became kind of more loggers, but this would be like a Z logger. This was like a Z logger any string. And there were just, I think there were in total like 6 of these different fields.
To quickly clarify, just to say what an executor is, in case people don't know, that's basically what you submit tasks to. That's what's actually going to schedule some computation to run on a thread. Probably most people know that, but in case not.
Yep. And yeah, it's kind of just the ZIO version of like, if you're used to like Scala concurrent, there's like that execution context the future needs, or if you're going for a Java background, there's an executor service. So it's just something you can kind of submit work to. It's a thread pool. And then in ZIO2, there was a logger that was part of that. There were these things called supervisors that we'll talk about a little bit more, that basically get to like observe lower level events in the runtime. And there were just these things. And so in a way, it was like a nice model that like there was just this like one case class. And so then when you actually had a runtime, the runtime would basically just have this runtime config. And so that was also like a little bit nice in that way, in that if I wanted to kind of create and this runtime would actually have as well a environment. That in ZIO2 was the environment. And so in a way, it was very nice that if you wanted to create a new runtime that had your own configuration, you could just create your own runtime. You could stuff a runtime config inside of it. And so it was very in a way, very straightforward that way. So that was the way that it was done in these earlier versions. But this also actually had a couple of issues with it. And so one issue that so maybe we could say like advantages. I think we could say, right, this is just like very simple and straightforward, right? This is just data in this case class. Want to modify it, just modify the case class. However, there are also a couple of issues with this. So one of them is from the perspective of concurrent state, having this like one big block of state is not ideal, because anytime we want to modify this, like potentially concurrently, right? Like maybe we have one fiber that wants to modify the executor, and we have someone else that wants to modify the loggers, and then we've got to be able to put those things together. And so that actually was one of the reasons we built in the support for what are called compositional fiber ref updates. So now whenever you do updates to these things, they're just patches. So that will actually do the right thing, but there's still just an efficiency cost of the fact that we've got to now have these two different fibers that are interacting with this one piece of state. Whereas what we'd really want is like, if all I'm doing with the executor, it shouldn't matter if someone's doing something with the logger. So this kind of led us to push to break these up into separate fiber refs. So like now, if let's see, I wonder if I can, let's see if I can can I click into the runtime for us here? And let's see, fiber ref. So like now, if you look in ZIO, each of these things is its own fiber ref. And so now when I update any of these things, I can update them just updating that one thing. I don't have to update anything else. So that actually makes these operations more efficient in the runtime. So I think one, we've got this, well, okay, let's go back up here. Lack of efficiency in updating concurrent state, right? That everyone is sharing this one state, even though, say, different parts are independent. In addition to that, there's a little bit of an issue here with what we could call extensibility, where like this is kind of building in this concept that there are these like blessed parts of the runtime config that like, you want to know what the runtime config is? It's these 6 things. And that's a little bit not ideal, because maybe these are the 6 things right now, but maybe we're going to do other things with the runtime in the future, where maybe it's going to have 7 things or 8 things. And so one of the nice things about this approach here is you can see it's a little bit more extensible, where we just have these different fiber refs. And if I want to have a different thing that's part of our configuration for how the runtime works, I can just add new ones. And because these are each independent pieces of data, they can just sit there independently, and then I can expose my own operators for them. So it's a little bit more extensible that way.
We did get a question from Naveed about, are changes to configuration at runtime really that big of a use case? Because it sounds like maybe that's the detriment, that this is difficult. The case class version is difficult to update, but how often are we updating it? You know, it would be the question.
Well, it kind of depends on what we're doing here. So I think some of these, like the executor, we got to remember that this is not just the executor we start with, but it's the executor we're running on. And so if we end up shifting thread pools a lot, then again, depending on what we're doing, we may end up changing that a decent amount. The loggers we're using, maybe in simple cases, we're using the same logger for the entirety of our programs, but maybe we have certain sections of code where we say, well, we want to log this part with an additional logger, or we want to remove a logger, or we want to add a supervisor for this. So, definitely for simple cases, we may just have the whole thing, but we want to make sure we're as efficient as we can be in supporting those cases where this changes for different levels of the program.
Mm-hmm.
And then I think the final one that's actually maybe the most important one from a, actually maybe I'll come with two more that I think both are a little more user-facing. And so one of them is, you can see here that these interfaces here don't involve ZIO workflows. And so what that means is anything we want to do here, we can't return a ZIO, right? Because this isn't expecting a ZIO, it's just expecting a new runtime config or a new runtime. So let's take the case of like adding a logger. Now, maybe a simple case, like the logger basically has an interface, like let's just say in a very simple world, so let's just say it has some interface where it just says it can log something. So in a very simple one might be something like a console logger, right? So I could do like object logger, and then I could do like, follow usual pattern, final case class, let's say console logger, instance logger any, and so this will just log by print line. And so this will be,
oh. There we go.
So this is kind of fine, but we can imagine like this is a little bit of a toy logger. Like any real logger we have, we're probably going to need to do actual work in constructing this logger. Like maybe we're going to have to open some file that's the file we're going to log to, and we need to close it when we're done. Or if we're doing some, right, we may need to load some configuration information from a file that like tells us which logger we're supposed to use, or like what credentials we're supposed to use with it. So what became unfortunate with this older pattern is that essentially it forced us to not use any of the nice ZIO tools we had when we were doing these runtime configurations, right? Because if I want to like define my logger here and add it, like at least this interface here doesn't let me use ZIO workflows. So if I need to like open my file and make sure I close it, like I can't use scopes or zmanaged or any of the stuff that I'm used to. If I need to do something asynchronous, I can't just use like promises. I have to like go back to kind of that lower level. And so that created like I think a pretty undesirable inconsistency where ideally we want to like, we're learning about all the ZIO stuff, right? We kind of love the power we get from it. We want to be able to use it everywhere. We don't want to have cases where we like have to drop back down to this like side effecting world and think about our code in a different way. So I'll say not able to use ZIO workflows or capabilities like scope in configuring the runtime. And then the other thing that just got a little bit annoying about this is it created a little bit of two ways to do different things. Because if we wanted to like add a supervisor or we wanted to add a logger, we needed to do it through this world of kind of modifying the runtime config. And like in early version of ZIO2, there was this like runtime config aspect that you would use to use it. But like that was kind of one way to do things. But then if you wanted to do any like ZIO things, you had to do layers. And so you ran into situations where, like in ZIO ZMX, which is this library built on ZIO for like metrics and monitoring, if you wanted to actually get your metrics working, you had to do two different things. You had to like create this layer that like started up the metrics monitoring service and did all these like ZIO workflows to do that. And then you also had to have this like runtime config aspect that like added the supervisor that hooked into that. And if you did only one of those two things, didn't do both of them, then things just wouldn't work for you. And so that wasn't great. And so in ZIO 2, we've moved to this world where everything is a layer. And so let's maybe, I mean, I think this has been good, like little pseudocode to like introduce, but let's like try to actually demonstrate some of this. So maybe what we can do here is we can just do extends ZIO app default. So let's start with like the most basic thing we could do. Let's just get this going. Okay, let's get this running. And this is 16, hopefully at the bottom, lovely. Okay, all right, so now we've got this going. And so now our question might be, okay, let's assume this is our program here. In reality, our program's gonna be doing more than saying hello, but we'll start with this. How could we customize these features of the runtime? And so the most basic answer is if we go to the runtime companion object here, let me see if I can do that here. There are just a bunch of these constructors on the runtime that each give us layers that are going to modify the runtime with whatever we're doing. So we want to add a logger. Well, we just have a layer that adds the logger. We want to add a supervisor. We just have a layer that adds the supervisor. And we've got a bunch of other ones here. We can see there are some different, what are called flags that just are basically kind of Booleans of like yes or no, of like do this or don't do that. We can set the blocking executor. We can set the executor. We can modify our definition of what's a fatal error. So we can do all of these things, and they're just layers. And so, I mean, Kit, I think, is really good at singing the praises of layers. But I think the nice thing about them being layers is we can do ZIO effects in them, and we can compose them into other layers. So maybe we already have a layer that like provides some services that our application needs. Maybe we're just gonna add in one more layer that sets the executor or sets the blocking executor or adds a logger. And so we can just build this like package of kind of all of the setup that our application needs, whether it's services we need or configuration. And one of the things to notice about this is this is reflecting a little bit of, I think, an emerging pattern of you have these layers that return the unit value. And so I think historically, and especially in ZIO 1, whenever you had a layer, it would usually actually return some service, right? It would be the layer that that constructs the logging service, and it would actually return the logging service, or it'd be a layer that constructs the database service. It would actually return the database service. But what we've been finding pretty useful, and it might be helpful for you to also think about in your code, is these layers that actually don't return a service, but essentially just do some setup when they're started and tear down when they're done. So like if we think about this like add logger layer, what this is gonna do is it's gonna add a logger at the beginning of this layer when it gets constructed, and then it's gonna remove the logger when this layer is done. And so it doesn't return anything itself because we don't actually need the logger, we're just setting the logger. But it's kind of wrapped up in this layer this way, which handles both the setting and the unsetting, and also makes it easy to compose with everything else. So yes, I think Kit is going exactly the right direction of let's kind of try to make this a little bit more practical, and let's see how we would implement our own logger.
Yeah, I don't see the interface there.
Let me, let's see. Will we get some help here? Maybe not.
Just the guess of Copilot.
Yep. So it's a little bit of, it's a little bit of a lower level interface, but I think we can say
Und.
See if that's...
Let's do something very silly here.
Yeah, well, first let's just make sure this is compiling.
It needs a message.
I think that's just the first type. So I think that's just...
I see.
Okay, there we go. Yeah, so, and I mean, I think maybe this is also like part of what I think we're going to do here is hopefully this will be helpful for like thinking about all this stuff related to the runtime config in general. So it's probably not a terrible idea here to spend a minute on this zlogger interface. I think probably in most cases you won't actually have to work with this yourself, but kind of the value I think of the Zymposiums is we get to go into a little more of this stuff anyway. And so basically this zlogger has these two type parameters. So the first type parameter is called message here, and that's basically the input that we're logging. So typically that would be like, it might be a string, right? That'd be a very typical thing, or it might be any, because we just say, well, look, whatever you give us, we're just gonna call toString on it. So you might as well give us whatever you want. But the reason that this is a type parameter is this way you can also define loggers that do more structured logging, right? So instead of just being like a string or any, it might be, you know, your application log message, and that might be like a case class that like, or like a sealed trait that says, well, here are these 5 types of like log messages we support, and you can do that as well. And then the second type is what's called the output type here. A lot of times this would just be like unit here if this is actually going to be like doing the sending the log somewhere. But part of the idea of this is that you can potentially separate out a little bit of the creation of the log outputs from where you send them. And so you can actually compose these loggers together. So you might have one logger that like takes your like application specific messages and converts them to, you know, your particular log format you want. And so maybe this output is like another like sealed trait with some case classes inside it. And then you might combine that with another logger that like actually takes those things and like sends them to some third-party service or something like that. So it's a little bit of a powerful interface. I think as you can see, just based on those two type parameters, as well as the relative complexity of this method, just because we want this to be powerful enough to support you know, any kind of real industrial strength logging you want to do. But in this case, I think we'll be doing something much simpler here. And then the other thing you can see from this is, so the loggers define this one method that's called applied here, but if you wanted to, you could really think of it as like log or something. And it just gives you all of these inputs, and it lets you use them to construct your output. And so in this case, we're going to do a logger that's actually going to log something. So it's doing the right thing here. He's just printing this with a silly message. And we can see we get access to a lot of different information that we want. And so the most basic is this message here. So that would be like the thing we logged, right? So like if I log hello world, this is going to say silly message hello world. But it also gives a lot of other information that we might want. So it gives us the ID of the fiber that we're logging the message from. So this is kind of like the name of the thread, which is, you can imagine, right? Probably if you've used other logging frameworks, this is something you would see a lot. You can also see the trace of like where you've come from here. You have this concept of log levels. So like you can log this at the, you know, the info level or the debug level or whatever. If you have a cause of failure, you'll have the cause here. Otherwise, this can be null. So that's kind of an example of how this is like definitely a lower level interface. You get to see these log spans. So that would be like this tree structure of, I think we've done some examples of this. I think maybe when we were demonstrating fiber refs of how you could kind of log in different scopes. So you could kind of see where you were logging in. And then you also actually have the ability to get these log annotations, which is this arbitrary, just kind of string information you add to it, right? So you might add different tags to it. And then you also have this thing that's even more powerful, this context, that actually lets you look at all the values of any fiber refs in the application at this time. And so that lets you do potentially more structured log annotations. If you have your own fiber ref that isn't just a string, but that maybe lets you do the log annotations as well, being some kind of seal trait or case class. But in this case, we don't really need a lot of that power. I think it's got a nice implementation here that's just going to print out some stuff for us. And so then our question could be, okay, well, how are we going to add our logger to our application here? And so the way we can do that is we can do dot provide layer runtime dot add logger. And I think let's make sure we got the right one. Silly logger. Okay, let's try. Let's see.
I think we want this to be also, oh, it's sad for some reason. Value add logger is not a member of, oh, because it needs zero.
Yeah, well, or maybe we should just delete my little fake runtime. Yeah. That's probably a good idea. Okay, so that's gone.
And then I think we also want to actually call log instead of console.
Yes, that will be the important, or
ZIO.loginfo, right? ZIO.log. Yeah. Let's do that.
Hmm. Cool. Okay, let's try running that.
Hey, silly message. And we got both loggers, right? So it adds a logger to I think a set, right? So we have the default logger is the first one with the timestamp and all that. And then the silly message is the one that we created.
Yeah, and that gets exactly sets us up for one of the features I wanted to talk about, because I think this is sometimes something that people have questions about, because I think sometimes, so you see this first message here. This is the default ZIO logger, and it's basically just a console logger. I think Kit may go back at some point and make this super pretty and beautiful. But this is just kind of the developer mode logger of, like, if you log something, like, even if you don't have anything fancy set up, we want to like show you something. So that's great. We need that. But sometimes when people add their probably not silly logger, but their industrial strength logger, they may not want to get these log messages anymore. And so there's actually another layer that was, I think I added it after RC6, so I don't think we can add it right now, but there's one called remove default logger that you can use to remove the default logger. But this does start to get at this idea that if you go back to these different features of the runtime here, one of the things you'll notice about them is there are a lot of things like sets, and there are also a lot of operations to add things, and very few operations to remove them. And the reason that we do that is we want to make these runtime configurations make sense when you're combining different programs. And so in particular, if you go to this ZIO app default, you'll see the ZIO app default has this layer that's called bootstrap. That is where for your ZIO app, you could define some of these basic configurations. You could like add your logging, or you could do stuff there. And one of the properties of these applications is that you can combine them together. So you see, if you have an application, you can combine it with another application to get a new application that'll just run both of those applications. And when we do that, we combine the configurations of two of these applications. So one of the things we want to do in general, when we have these changes to the runtime config, is we want them to be compositional. And if we think from I guess, a little more theoretical perspective, ideally, we would definitely want them to be associative, and ideally, we'd even like them to be commutative, where the order in which you apply them doesn't matter, because you might like be joining two fibers that each want to make different changes to the runtime configuration. And so if we're doing things that are like adding things to a set, that's commutative, right? If one person wants to add silly logger and another person wants to add serious logger, well, that's fine. We'll add both silly logger and serious logger to the set, and everything will work. Versus if instead we had like a runtime set logger, and one person wants to set the logger to the silly logger, and one person wants to set the logger to the serious logger, then we've kind of got this like indeterminate situation of like, which logger do we use? And like, we kind of end up like trampling on each other. So we've tried to set all these up as much as we can so that you're preserving information there. In some cases, there's just a limitation, the underlying domain on that, where like there's an executor and we have to run the effect on only one executor. So in that case, like there's kind of last win semantic, but where possible, we're trying to make this compositional this way. And so it looks like he has added a serious logger here. And so let's try running that.
Yay.
And yay, so we got the silly message and we got the very serious message.
Also, because I don't think we've talked about this before, but this is the provide macro.
Yeah.
And if you have a layer that returns a unit, it will just add that layer to the other layers. It'll build that layer and do sort of the same thing as we just looked at. So I think that'll actually give you a warning. Maybe we could just even show that idea of having sort of some side effect.
Yeah, let's do it.
Layer, which would be, I could just do Z layer and then do ZIO.acquire release. So I'll just here do ZIO.debug starting and then ZIO.debug stopping. Let's just do that. So this is I don't think I could add the type, but I'm guessing that's a Z layer.
Let's see if I can do it.
Of units. There we go. Oh, and sorry, Z layer.scoped.
Yep.
Because yes, we're wrapping an acquire release. So that's the new version of Z managed. It's just going to be a scoped in the environment. And if you want your layer to both start and stop and sort of handle that scope, you say Z layer.scoped. And so now if I throw this in here, side effecting layer, it's just going to build it. And that's kind of the functionality we're going off of. Could you run that again?
Mm-hmm.
Just to make sure that it says starting and then stopping. So
yeah,
starting, then it runs their application, which just logs to 3 different loggers and then calls stopping. And if this weren't of unit, if this were of something else, let's say I did, as 10 or something, could you try to compile this?
Mm-hmm.
I hope.
Ooh, I think we would save.
Ah, gotcha.
Yep,
so
there we go. Let's
so if you scroll
up. Yep.
So it says you have provided more than is required. You may remove the following layer, side effecting layer. And I think if you scroll down a little bit, will it warn us? Oh no, it will not warn us. But so usually, or it won't give the tip to make it say unit. So basically, in this case, it's going to treat this as a superfluous layer because usually there's sort of these 2 ways that you can use layers. One is to build your application's dependency graph. The other one is this sort of pattern of running side effects, scoped side effects. And so if you want a layer to be included and to run as a scoped side effect, you would have to have it return unit. And you could just call .unit on that layer to do that. That warning will go away and it will build it. Otherwise, it will not build it. And it's a side effect. I think, and for some variant, I have it give a warning. So now it no longer says the starting or stopping afterwards because it emitted a warning saying that this was unused essentially. But if you want to sort of signal that something is side effecting, either make a return unit or chain unit on here, and that can be a nice pattern. I think I'm going to add the documentation to recommend making it, describing that bit of behavior. I think it does that in some case, maybe with provide some or something. But yeah, I did that at some point. Maybe it's gone. But yeah, just a fancy little trick you can use with provide and layers that return units to do this sort of side effect, scoped side effect pattern.
Yep. Do we have any questions before we keep going here?
Let me check the Discord. No, nothing in the Discord.
Okay. All right, great. So I think maybe the next thing we can do then is, so we looked at the logger here, and I think the logger has a fairly straightforward interface. Now, maybe one thing we could actually do that would be fun with the logger here is let's think a little bit more about what we would need to do if we needed to perform some ZIO workflow to construct one of these loggers. So maybe we could say, like, what if we generalized these loggers? Like, what if this was actually
make logger?
Yeah, well, I was gonna say, I mean, I'm playing with our like. So let's say that this thing took some mood of like, should it be silly or should it be serious? And so then I think we could refactor these to just call that, right? So this could be mood logger. This one was what? Super serious message, very serious message. But then let's say that we wanted to be able to get this information from a file here. So I wonder if we have the stuff from that you did, Kit, to make this a little bit nicer in this version. Let's see. So I think we should have a ZIO dot
from file, a read file.
Read file. So read file.
Yay.
Okay, perfect. Yay. So yeah, let's say we want to read from a file. That's this mood.txt. And we want to use that mood. And then we don't want to print it. I think we can actually just, maybe in this case, we'll just return it. So this is going to be, let's see if I can, oops, that's not right. It should be a ZIO, any, I think IO exception string. Let's check. Okay, perfect. Okay, so I got this thing, and let's see, okay, perfect. We created a mood, wonderful. Oops, let me see this.
Should we do that?
Yeah, that looks fantastic. So now this is a layer that's going to return a logger.
And well, it's not a layer yet. I guess we should say, should we make this into a layer? It's just, this is just a ZIO of a logger right now.
Yeah, I think that's probably a great thing to do. Yeah, I think that should be fine. And so we could do that. We can make this Z layer. And so now that we have this, then we might say, maybe I'll call this like add mood logger, say. And so I think I can just use, at least one easy way I can do this is I can use a for comprehension. I could change this. So I could say for logger in mood logger, and then this in runtime.add logger yield unit.
I think that, well, we'd have to call logger.get in that regard.
Oh, so let me. Yep.
And then we'd want to,
Let's see.
Oh, it needs to have a Z environment, yes.
Oh. Okay. So let's see if I can add this in. Okay, perfect. And then maybe I'll make this, yeah, okay. And so now, let me maybe take these and I'll do add mood logger.
And I created a text file already, so that should work.
Yep, so let's try running this. Okay, so now we're logging and our mood is completely insane. But so we see here how, I mean, in this case, we weren't really doing that much here. I mean, well, this read file is actually, I mean, it's safely opening the file, it's safely closing the file, it's safely managing those resources. So that's great. But we could imagine that this could really now build in like any kind of ZIO workflows or any kind of finalization that we needed to do. So it could maybe be more like this logger is going to like send something to some external server, right? It needs to like open the connection, it needs to close the connection when it's done, and it needs to like retry the connection if it fails, and needs to like encode and decode things. And like all of that could be like done in this implementation here and could use all the nice ZIO stuff that we're used to.
Yeah, I suppose maybe another way of, I mean, the one, so in case people haven't used for comprehensions for Z layers, the one tricky business about it is that sort of the left-hand side gets you a Z environment of your return type. So you have to call get to access the actual underlying value. That's because Z layers compose these maps of produced dependencies or produced services. In this case, it's only one, but nonetheless, it still has to return that so-called Z environment type. I suppose another way of doing this as well would be to, instead of having this be a Z layer here, we could just do the ZIO effect like this, and then we wouldn't have to call get here. Of course, this would just get us back the final layer that we could return directly. So we're now going to have a ZIO effect of a layer, and we could sort of do Z layer around this, and then call flatten on that to also do sort of the same kind of thing.
I think it's a nice pattern there.
Yeah.
Yeah, very nice. Excellent. Okay. So I think the main other thing I'd like to do is look a little bit at this supervisor interface. And so maybe to motivate that a little bit, like let's go back to this runtime thing. So add logger we've looked at. Add supervisor is the other one that I want to spend some time on, just because I think you might be like, well, what's a supervisor? Why would I use a supervisor? How do I use a supervisor? So we'll come back to that in a second. I think if we kind of scroll through most of these other ones, they're a little more self-explanatory. So set it the blocking executor. That's the executor is used for blocking tasks. Set the executor. That's the executor used for non-blocking tasks. The set report fatal, it basically lets you, so like by default, ZIO considers anything that's a virtual machine error to be a fatal error. And so it like wouldn't catch it. It would just immediately blow up the application at that point. If for some reason you wanted to consider something different as well as a fatal error, you could do it with this. I think that's a little bit more just like it's a setting, so it exists there if you want to change it. I'd be a little bit hard pressed to think about a situation where you would actually want to change that, but I'm sure someone will come up with one. So I think those are the ones that like take a parameter, and then you have a couple of these that set one of these flags. And these generally enable specific features. So like this enable current fiber basically kind of tracks every time a fiber like starts running and then stops running. And that supports some integrations with this functionality if you want to treat a fiber ref as a thread local, or you want to go back and forth between the two of them, you need to have that enabled. Or like this log runtime, this will like actually log things about the runtime itself. So it has some performance implication because you're just doing a lot of logging, but if you want to kind of do stuff at a very low level, then you have that. But so in particular, I think it might be nice if we look at this supervisor interface. Mm-hmm. And so a supervisor is definitely a lower level interface. Let me see if I can get down on here. So it's got a couple of methods on it. So the first one is this value method that just lets you get some result out of type A. So that's, you could think of as like the result of supervision. And then it gets defined with essentially these callbacks. And so there are these 5 callbacks here. And every time a fiber does one of these things, the runtime is going to call this callback for each of the supervisors that's active. So every time a fiber is started, like when you do a fork, this unsafe on start is going to be called. And you're going to get to see what the fiber is, what its parent is, if it had a parent. If you need it, you can see the environment at the time, the ZIO effect. I would say these are probably the things you're going to want to use most. Then this thing is going to be called every time the fiber ends life. This time, this is going to be called every time it evaluates an effect. This time, every time it suspends. And this time, every time it resumes from suspending. And so you can imagine, like one of the early use cases was there was this library that was developed for ZIO called Panopticon. And the idea of it was kind of like a visualization library for these fibers, where like you would be able to see like all the fibers in the ZIO application. You'd be able to see, this fiber was a child of this fiber, is a child of this fiber, is a child of this fiber, and you'd be able to kind of zoom in on that and like have a nice like use visual application to look at that. And this is the functionality that application could use to get its data, where essentially the way it would hook into ZIO would be it would add a supervisor, and the supervisor might maintain its own little like map of the fibers, or probably more complex data structure than a map. But essentially every time a fiber did one of these things, the callback would update that data structure. And so maybe we can create a simple implementation of that. So let's go back here.
Silly supervisor?
Yeah, let's do a silly supervisor. Perfect. So I'll say val silly supervisor is equal to new supervisor. And I'm going to start with having a supervisor that just does a side effect. We'll look, I think, after this at how we can update some state here. But I think the side effect case is actually pretty common. And so I'm going to grab these.
Want to just do the on start one? Oh, I guess we need value as well, right?
We need to implement value just as one of the abstract methods. Oops, I don't know how I got that. But yeah, I think we'll start with these. Let's see. Okay. Yeah, nice. Okay. So let's start with like the silliest example. So we could just say something like, yeah, that seems like a perfectly good thing to say. Go Copilot. Okay. So we've got our supervisor, and I mean, it's okay if we had the mood logger as well. So we could say dot provide, what do we call this? Silly supervisor. But we need to actually add that. So runtime dot add supervisor, silly supervisor. Okay, now let's try this. I think we may not have a whole lot exciting to show right now because we're not doing a lot of fibers, but let's just try running this. Yeah, so let's try doing something in here where we actually have some stuff for supervising.
Build ZIO dot, or sorry, like ZIO dot collect all par or something, and do list dot fill 10 with the logging or something like that.
Yeah, I think
that would.
I think that should hopefully trigger something. Yeah.
Oops, list dot, oh yeah, list dot fill with that. There we go.
Okay. Let's show something.
Hey. So we got a bunch of starting at the top. Yeah, we got 6 starts, and then all the logging, obviously, each from a different fiber. Cool.
And then all these ended.
Yeah, maybe we should log with the fiber ID or something as well, fiber.id. Clearer than the actual ZIO effect.
Well, I think we're already doing fiber ID. I think maybe here we could do like parent.
Sure. Oh yeah, we are. Sorry, we are doing that. Yeah. Started on parents.
I think this one doesn't have a parent.
Oh, it doesn't. Oh, you're right.
Yeah, it's just because kind of the assumption is like if you're doing something with this, you already knew about the start and you knew about its parent from the start, so you don't have the parent here as well.
I see.
So I think what you had there was probably perfect. Okay, so let's try this.
Oh, there's one sad thing about, I don't know, it looks like it's surrounded in square brackets, but there we go.
Okay, let's try running that again. Okay, and now when we go up here. So yeah, and you can see, I mean, this is obviously this little like console interface is not the most beautiful way to see this, but I think you can see already how this is giving you the information of like, okay, I know 9 was started from 6, I know 10 was started from 6, I know all 5 of these fibers were started from 6. So this, if I like had that information and I like used it, I could like make something that was like, had a nice like tree and kind of showed 6 at the start of the tree and showed 9, 10, 11, 12, 13 below it. And then once I got these events that like 13 had ended, then I could like either I could like take 13 away, or maybe I like recolor it, or I do something else with it. So this gives me a lot of ability to access like low-level information from the runtime here that can be useful for either like visualization tools like this, or various other integrations with like low-level functionality. So like another ZIO contributor, Dmitry Karlinsky at the ZIO Hackathon, introduced a feature of ZIO2 called the thread local bridge that allows you to kind of take updates and send them to thread local. So there's some nice like functionality you can do with that that's useful for things like context monitoring or solutions like this. Let's see. So what did you just?
I added a layer of nesting in case you wanted to see the child have a different parent.
Yeah. So let's go back to the parents at the top.
So yeah.
6, 6, then 11 gets forked from 10, which 10 was forked from 6. So yeah, you could see how we could like start to like kind of build something to keep track of this.
Yeah.
And maybe that actually leads a little bit to where that like value thing comes in here. So this value thing is, in this case, it's not really used at all, because like all we want is to do these effects. But if we want to, we can imagine that maybe when we create the supervisor, we maintain some kind of internal state here, right? I do like new. And we could imagine like maybe the state is like actually like a tree-like structure of like, right, I can have like a fiber or like a fiber node, and it can have children. And so then maybe these unsafe on end and unsafe on starts actually just update this reference here. And then if I want to do something with the value of it, this then becomes like the state here, right? And this would be like ZIO.succeed. I need to do like val state equals. And then this could be like state.get.
Mm-hmm.
And then this could return like state here. And then I should probably.
And so I'm guessing we could have, we would make one of these supervisors and have hold a reference to it, and we can sort of access its value and use that to, show a dashboard or something.
Exactly. And that's also where the functionality of these being layers comes in. Because I think a pretty common pattern when you do this is you would have something like, let's say, val supervisor layer. And you would basically, a little bit like what we did with the logger here, is you might use some ZIO workflows to create the supervisor, or maybe you just do it in a purely side effecting way. But then you would take the supervisor, you would create it here, and then you would also install it, right? So you might say, well, in this case, we already have the silly supervisor here, but you could potentially inline the logic here, and then you would include the runtime add supervisor here. Mm-hmm. So like we can, maybe in the simple example, we can just extract it here. And then this just takes care of everything of adding this. So from the user perspective, they just need to add this one layer, and this layer is going to do anything it needs to do to both set up this supervisor, which like in this case, it was just printing. But again, just like our prior example, maybe it's not going to print, maybe it's going to send this to some third-party service, each of these events. So it's going to set that whole thing up, and it's going to be able to do any finalization of like shutting that down when it's done. And it's going to add the supervisor to the runtime. And so we'll just get to provide our users with this one layer that kind of does everything for that. So that's like, I think the ultimate like power of this, of like, as a library author, you get to implement this one kind of master layer, and you tell your users, look, just throw this on to the layers you're providing, and this is going to do everything you need to do.
Yeah, and it could even, maybe with metrics, start up a development server, right, on some port, right? And these can be configurable layers as usual, right? They can either require another config layer or just be methods that accept some configuration port. And then you can imagine, yeah, it'll install metrics and start up on localhost, whatever, some customizable port, sort of a quick and easy dev control panel.
Yeah, and that's like exactly the interface that like ZIO ZMX is providing in ZIO2 of, yeah, you just do your kind of metrics layer and it just sets up everything for you. And I think depending on which one you use, you may also provide like a metrics config layer that says something about how you want to set it up, but that's all you do when you're done.
Well, fancy.
Any questions on any of this?
I don't see any in the Discord, but yeah, are there any sort of other besides, I guess it sounded like that's one of the points you mentioned earlier about the extensibility, because these are all just sort of fiber refs under the hood, or the runtime config isn't a thing itself. It's not a concrete data type any longer. And it's really just a bunch of fiber refs, right, that these things hold on to. It's extensible, right? So even if right now we're only doing loggers and supervisors, but in the future, if we figure something else that needs to be involved in the runtime system, you could just add that as another fiber ref without breaking down compatibility or something.
Yeah, and also, I mean, you can actually essentially do the same thing yourself, where you saw kind of all this stuff that was being used internally by the runtime was fiber refs. And we did another session before on how you could use fiber refs in your own code. So if you had some fiber ref that you were using in your own code, maybe that was wrapped up in some kind of service that was like, I don't know, maybe you had your own implementation of the logging service that had like a log level that was part of that you could have your own like layer that would like maybe just start with an application level scope for your log scope, or your yeah, I guess log scope is a perfectly good word. But you could just say, yeah, I want to kind of do the whole thing within that scope, and that would be fine too. So yeah, it kind of unifies everything where there's not like, at least really, there's not a different way that we do configuration. We do configuration through layers, just like we really do all setup through layers. And maybe it's like it exists in the runtime companion object instead of somewhere else, but it's all really the same thing, which is one of the nice things about this.
Yeah, it's just the runtime companion object seems to be very much just a companion object. It just is a bundle of sort of patterns that wrap fiber refs and maybe make it easier to update sets of fiber refs or something, and it has this patch logic built in that happens to be very useful when dealing with this configuration type stuff where we want to add and remove sets of loggers. But yeah, it's really just a nice layer atop everything. To use the word layer, on top of everything else. So that's nice. It sounds like you've dissolved another concept. So cool. Well, yeah, I don't know, we're at an hour. It seems to be our new magical.
I think that's good.
We're either getting more efficient or less interesting. I don't know, but that's good. It would be cool one day to take a look at. I'm not sure if we could add it to our old toy version of ZIO or just discuss the implementation, but how fiber refs work, because I've peeked a little bit into that, but it's kind of interesting what they are.
Yeah, definitely. Cool. Yeah, and that could also be cool to do maybe as if we do something about like the new runtime after that comes out.
Yeah. We'll have some good stuff once ZIO2 drops.
Yeah, we got lots of good stuff. All right, well, awesome. Well, thank you so much, everyone.
Merry Friday. See y'all next week.
Bye.